Welcome back to this video series of C++ programming. This is the lecture 11 of this video series, and today we are going to discuss about constructor and destructor, which is one of the very important topic of C++ programming. So let's begin. First we'll talk about constructor. The constructor in C++ acts like a function which is invoked when new object is created. So it is kind of a function and it is invoked as soon as you create a new object of a particular class. Constructor is used to initialize the data members declared within the class to a user-defined values. By default, when you create an object of a class, all the data members holds a garbage or zero value. But with the help of a constructor, you can initialize those data members to a user-defined or the values provided by a user. The name of a constructor must be same as that of a class name. Let's talk about these 3 points with the help of an example. We'll discuss about the constructor with the help of an example of a stack. So what is stack? Stack is a linear data structure and it is used to store the data or elements. Stack is also called as a LIFO, which stands for last in, first out. So it's a LIFO data structure. And why it is called LIFO? Because the element which is stored last on a stack is taken out first, and that's why it is called as a last in, first out. Stack is typically a part of a RAM or random access memory in the processors, and it is used to store the temporary variables or the function arguments or return address of a function. So stack plays very important role in between the function calls. So when you jump from one function to another function, the stack is widely used to store these temporary variables or return address of a function. Let's see how does this stack looks like. This is the memory layout of a stack. So data elements are stored in this stack in the least in first out order. So suppose this is the empty stack, and if you want to store any element, first it will go to this lowest address and then the stack will be incremented. So next element will go in this address. So likewise the elements are stored in this order. While retrieving the elements, the element which is stored at the last is taken out first. Suppose now this is the uh, element stored in this address, which is the last element. While retrieving, first this element is retrieved, and then it will go in this down order, and finally the element which was stored first is retrieved at the last. Oh, this is called as a top of stack. So the highest memory address which is pointing to this stack is called as a top of the stack. Typically, stack has a size. So assume now our stack is of 100 bytes wide. So let's assume this is the 1064. So it is starting from the 1000x location and will go to it 1064. So 64 is a decimal hex equivalent of 100. This is one variable which is used to maintain the stack. So call this as the top of the stack. Now here we create one class and we'll call this as a stack. Inside this stack we'll create some data members. Now this is stack. This variable, it is an array of a integer data, and this is actually representing this stack. And the size of a stack is user defined. So let's define the size of stack as 100. So 100 data elements can be stored in this stack. Similarly, I'll create another variable and I will call this as a TOS, which is top of the stack. So this is used to maintain the stack or check the current location of the stack. Similarly, we'll create some public members. We'll create one function that will use to store the data onto a stack and another function that will retrieve the data from the stack. Typically, in case of stack, the terminology that is used to store the elements is called as a pushing the data on stack, and the terminology that is used to retrieve the data from stack is called as a popping from the stack. So here I call this function as push, and we'll pass one value, integer value, to this function, and we'll store this value in this variable. First, we'll take out this function from this class and we'll define it outside the class. So you have to provide the membership label and then the function name. So we have to declare a prototype for this function in here. Now this function, when it is called, we are passing one value to this function, and this value is stored into the stack, and the index is this TOS variable or top of stack variable. Now, as we discussed, whenever you push a value onto stack, it is first store at this lowest. It is first start storing at the lowest address, and then the stack is incremented. Next time, when you push value, it is again stored in this address, and the stack is incremented. So in this case, when you are pushing, first we'll be storing in this stack, and then we'll increment this TOS variable, so it will point to a next memory location of the stack. We'll create another function which will pop the value from stack, and I will call this as a pop. When we are pushing the value, the stack variable, it is now incremented by 1. So it is, suppose now your data, the last value is at this location, but your TOS is actually pointing to this memory location, as we have incremented these values after every push. So while retrieving the data, you have to first decrement this TOS, and then we have to get the value from that stack. So here first we are decrementing the value and then returning the value from the stack. And inside this main function, we'll create an object of this class stack. So we'll call as a S1, and similarly I will create another object and I will call this as S2. Now with this help of this object, we'll push certain values onto a stack. And here we'll write a function that will take the value from a stack. So here we are pushing the values, and here we are retrieving the values from a stack for both the S1 and S2. Another important point to remember about the stack is the stack has a fixed size. So in this case, assume it is a 100 byte size. So we have only 100 bytes of a memory available. So if you are storing more than 100 bytes of a data at the same time, or assume your function has 100 bytes of a data or local variables which you are pushing onto the stack, then after the 100th value, if you are pushing any other new value, then your stack will overflow. That means you are going above this address, which is a invalid operation. You cannot go above this address because this address is reserved for some other purpose or some other data, and if you are storing in that memory location, then it might corrupt some other data. Similarly, this is the lowest address and you cannot go below this, so you cannot pop the data from the address below this base address of the stack. So there are some guards present in this stack. So this is the higher guard and this is the lower guard. So what is this guard? It prevents the stack from going above this address and going below this address. So the compiler will take care of this. So if you're typically when you use the stack, typically when you call the function, the stack is maintained by your compiler. So compiler will take care of these things. So if you're going above this address, it will give a error saying your stack is overflowed. And if you're going below this address, then the compiler will throw an error saying your stack is underflow. So in these functions, we'll check for those errors. So how to check the stack overflow error is if TOS is greater than size, that means stack is overflowed. Similarly, in case of a pop operation, if stack is less than 0, less than or equal to 0, then it is stack underflow. In case of a stack, the TOS variable must hold the 0 initial values, so it must index to a 0. But in our program now, this TOS has some garbage value, so we must first initialize these values of a TOS. So how to initialize? So we can initialize. One way is to initialize is creating another function called as init function, and through that init function we can initialize that values. But another way is to use the constructor, which is the topic of this our discussion. So now let's see how we can create a constructor to initialize the data members. Now as we talked, the name of a constructor is name of that class. So here now the stack becomes a constructor, right? So this is stack is also a name of this class, and the name of a constructor will be same as that of a name of class. So here we will define that constructor. So this is just a prototype here, and at this place outside the class we will create a definition of this constructor. So now this definition, this is a membership label which is name of class, and this is a name of the constructor which is same as that name of the class. Now in the constructor you don't have to specify, or you should not specify any return value, because the constructor doesn't return anything, but it is possible to pass a value to the constructor, which we'll talk in this video. Now inside this constructor we'll initialize this TOS variable to a 0, and here I will print one statement, stack initialized. As soon as we create this S1 and S2 objects, this constructor function will be called, and it will initialize the data members to a, or in this case TOS, to a user defined value which is 0 in this case. Now let's compile a program and let's see what does it outputs. So it is outputting this data. In this case, first two statements, they're saying the stack initialized. So this is the stack initialized for S1 and this is the stack initialized for S2. The next statements are the values that are popped from the stack. So this 4321 are the values popped from a S1 stack, and 8765 are the values popped from the S2 stack. Now let's understand about this output. So first, when you are creating this S1 and S2 object, it's first hitting this function, constructor function, and then it is printing this stack initialize function. So it's printing twice because we have created two objects here. So based on the number of objects, this constructor function will be called. Now we are pushing the values for S1 stack. We are pushing in this 1 2 3 4. So now fourth is the last element that goes onto this stack. So here 1 2 3 and 4 will be stored in this location. And when we are popping, first we are popping this location first, and then we are going in this down order. So that's why it is printing the 4 value first and finally 1. And similarly it is happening for this data or the S2 stack as well. So we understood how to create a constructor function to initialize the values of the data members. Let's discuss remaining points about the constructor. The constructor does not return any value. However, arguments can be passed to a constructor and it is called as a parameterized constructor. We cannot return any value from this constructor, but we can pass an argument to a constructor and it is called then a parameterized constructor. If constructor is not defined, by default the compiler creates one for you, the default one with no arguments. If you want to pass argument, you have to create your own constructor which writes default one. If you don't create any compiler, so if you don't create any constructor, the compiler creates one by default and it doesn't specify any arguments. If you want to create your own constructor, you can pass argument. So, and when you create that, it will override the constructor created by the compiler. There can be more than one constructor defined for a given class. Now let's talk about these 3 points with the help of same example. First point, we can pass a parameter to a constructor. Now in this case, we are not passing any parameter, so we are initializing this TOS to a 0. So we can pass the parameters to a constructor. And how to pass? Because the constructor, we are not invoking constructor manually. So unlike the function, we are not specifying any name to invoke that constructor function. But this object is, when you create object, compiler is automatically invoking that function. So only way to pass the parameter is with the help of these objects. So how to pass a parameter to a constructor is by using this object. So after s1 you have to specify these two brackets and inside this we can pass the parameters. So similarly for the s2. So here we have to now modify this constructor. So here I will change this argument and similarly in the prototype. So when the object is created, it is passing this value and then we are assigning this to TOS variable. Now this becomes s1 and s2 becomes a parameterized constructor. I'll create these two more objects called as s3 and s4. But when you create, the compiler shows an error which is saying no default constructor exists for class stack. That means now there is only one constructor and it is a parameterized constructor. So this constructor expects you to pass the value. But in this case, we are not passing the value to this object. So that's why it is giving an error. So how to solve this error is, as we talked, we can define more than one constructor. So I'll create another constructor and this time without parameters. So now this constructor will be used for these two objects s1 and s2 and this another constructor will be used for this s3 and s4 objects. So similarly I will have to declare the prototype here for the another constructor. So compiler is not giving any error in this case. This is a very powerful feature of C++ programming and it is called as function overloading. So you can specify the function, two different functions with the same name and both can then execute the same or different functionality. But you have to specify this different arguments when you are invoking that function. So in this case of a constructor, you can overload the constructor. So you can create the same can create the different constructor with the same name but with the different arguments. Now let's compile the program and let's see whether it is working correctly or not. So now it has printed this stack initialized 4 times. By 4 times because we have created these 4 objects. So in this case I will call this as a PC, which is a parameterized construction. Now it is printing this stack initialized and bracket PC. So this is because here first we have created these objects which are the parameterized, which uses the parameterized constructor and that's why it is printing this. parameterized constructor statements, so which is this statement. So we saw how we can create a parameterized constructor in C++ programming. So we talked about all these points related with the constructor, and hopefully now you are able to understand how the constructors works. Now let's talk about a destructor. As the name suggests, destructor is used to destruct or destroy something. But what it is? The destructor in C++ is invoked when the current object is destroyed. So when your current object is goes out of scope or it is no more used, it is getting destroyed. The destructor can be used to free any dynamically allocated memory. So if you're allocating any dynamic memory in your program, then destructor can be used to free that memory. The name of destructor must be same as the name of class. So similar to a constructor, the destructor name must be the same as that of class name. The destructor does not return any value, neither it takes any argument. So unlike constructor, destructor doesn't take any arguments, neither it returns any value. And finally, only one definition of destructor exists for given class. So unlike constructor, there must be only one definition of a destructor. Let's understand the destructor with the help of example. Here, similar to a constructor, I will create a destructor. But how to create a destructor? As we talked just now, the name of a destructor must be same as that of a class name. So class name is a stack. But problem is, constructor is also given a same name. But now to distinguish with the destructor, we have to provide this equivalent sign. So now this indicates a destructor. So here I will create a destructor. So in the definition also we must provide this sign. And as we talked, we must not provide any, we must not pass any argument to a destructor, neither we should return any value from the destructor. And here I will write a stack destroyed. Now when this destructor function will be get called, in this case these objects are created. So once we exit from this main function, from this location, these objects which are a these objects which are local to a function will get destroyed, and at the moment those objects are destroyed, this destructor function will be called and it must print this value. So let's compile a program and let's see what does it outputs. Now you can see it has printed this for statement, the stack destroyed. Why 4? Because we are using the 4 objects in our program. So all these 4 objects are destroyed when we exit this main function, and that's the reason it is printing 4 stack destroyed statements. So this is how destructor works in the C++ programming. Let's talk about the final point about the constructor and destructor, and that is the order of execution of a constructor and destructor. So in which order this constructor and destructor functions are executed. So when you are calling this constructor function, I'm printing this DOS value here. Similarly, in case of a destructor function, we'll print this DOS value. And inside this, I'm using these two objects S1 and S2. And suppose we are passing it these two values here. S1 we're passing the 1 and S2 we're passing the 2. These objects are local to this function. Similarly, I will create another 2 objects in the global scope. As we discussed previously, we can create object in this place also. So I will create this another object called as S3 and we'll pass the value 3 to this, and another object called S4 which I will pass the value 4. So we have created the 2 global objects and the two local objects within the main function. And here inside this we are printing, so whatever the values we have passed, we are assigning to this TOS and then we are printing that value. Similarly, when the object is destroying, we are printing this TOS value. Now let's compile the program and to see the order of execution of this constructor and destructor. As you can see, this is the order of constructor execution. So it is first saying stack 3 initialize, then 4, finally 1 and 2. Now this 3 and 4, these are the values passed through this global objects. So S3 and S4 are global objects. So when your program starts executing, first these global objects are evaluated and the constructor is called for them. So it is printing the values 3 and 4. Now when we enter the main function, we are creating the S1 and S2 objects. And so these 1 and 2 values are for the S1 and S2 objects. So this is how the constructor execution works. For the destructor works in the reverse order of a constructor, or the execution of destructor happens in the reverse order of a constructor. So as you can see, first it is saying stack 2 is destroyed. So if you see this, first the object S2 is destroyed, then the object 1, then finally object 4 and finally object 3. So this order is exactly the reverse in which the constructor is created. So this is how the constructor and destructor execution works in the C++ programming. I hope now we have covered the most of the points related with the constructor and destructor. We'll talk more about the constructor and destructor when we see the advanced topics of C++ programming like inheritance or polymorphism, and in that we'll talk about the other important concept about the constructor and destructor. For now, thanks for watching this video and stay tuned for the upcoming video.